Let's solve homework exercise number 12 from section 1.3 homework exercises. It states a vending machine accepts nickels, dimes, and quarters. Exact change is needed to make a purchase. How many ways can a person with 4 nickels, 3 dimes, and 2 quarters make a 50-cent purchase? Okay. Let's try and keep it organized, see how many different ways we can get. All right, I think the best thing to do is let's do it with quarters. So 2 quarters, 2 quarters is exactly 2 times 25, which we know is 50 cents. So there's one way of doing it with 2 quarters, okay? All right, let's go down to 1 quarter. So 1 25-cent. 50 cent, we could do 3 dimes would be too much, so 2 10-cents, 2 dimes would be 25, 20, 45, and 1 nickel would give us 50 cents. Okay, so there's a second way. Okay. How about with 1 quarter, and instead of 2 dimes, 1 dime shouldn't really be a dollar sign, should be a cent sign, right? Okay, cents. So 25, 35, and 15 more. So if we have 3 nickels, would be 15, would be 25 and 10. Well, here's 10. 35 and 15 would make 50 cents, okay? So there's a third way of doing it. How about with 0 quarters? 0 quarters, we have 3 dimes, 30 cents, and then if we have 4 nickels, 20 cents, 30 plus 20 is 50. So that would be a fourth way of doing it, 3 dimes and 4 nickels. If we went down to 2 dimes, we'd only have 20 cents, and 4 nickels would be a total of 20, 40. We wouldn't have enough. So this appears to be the 2 quarters, 1 quarter, 2 dimes, and 1 nickel, 1 quarter, 1 dime, and 3 nickels, and then no quarters, 3 dimes, and 4 nickels is going to give us our 4 different ways of getting our exact change. All right? So just keep track order. Try and work with maybe the quarters, 2 quarters, 1 quarter, 0 quarters, for your amount, and then keep track of the how many different ways you got it, and hopefully you'll get the right answer. All right, let's look at number 13. If there are 4 lamps in a room, in how many ways can there be 1 lamp that is on and 3 lamps that are off? All right, so we got 1, 2, 3, 4 lamps. Okay, 1 lamp is on. So let's say the first one is on, then this one is off, off, off. We'll just use F, right? Okay, then another way would be 2 would be on, this would be off, 1, 3, and 4 would be off, right? And then another one would be 3 would be on, 1, 2, and 4 would be off, and finally we could have the one that is on is 4, and then 1, 2, and 3 are off. So you look here, if there's 4 lamps, there's exactly 4 different lamps that can be, or one that is on, and then automatically other 3 are off. So we got 4 lamps, 4 ways of getting each one on. So like if we had 6 lamps, then there would be 6 ways of getting lamps on, 1 lamp on and 5 off, because you'd either have 1, 2, 3, 4, 5, or 6, right? So it would be 6 ways, okay? Or if you had 8 lamps, it would be 8 ways. All right, very good. Let's go ahead and put in the answer to make sure we've got it correct. So for 4 lamps, it would be 4 different ways. Either the first, second, third, or fourth would be on. All right, 5 people come to a party and shake hands with each other. If each person shakes the hand of every other person, how many handshakes occur? All right, so we have let's say person number 1. Okay? Now, he doesn't shake with himself, right? But he shakes with person number 2, 3, 4, and 5, right? 5 people all together. Okay? Person number 2, we already got 1 and 2 shaking. We don't do that again. And 2 doesn't shake his own hand or her own hand, so we simply have 3, 4, and 5. So here we have 4 handshakes. Here we have a total of 3. Okay, let's go to person number 3. 1 and 3 is already taken care of. 2 and 3 is already taken care of. 3 does not shake their own hand. So 3 is left with shaking 4 and 5. So we got 2 more handshakes. Person number 4, 1 and 4, 2 and 4, 3 and 4 are already accounted for. 4 and 5, 4 doesn't shake their own hand. 4 shakes 5, 1 more. And then person number 5, we've already got 1 and 5, 2 and 5, 3 and 5, 4 and 5. We've already got all the handshakes, so there's no more, and he doesn't shake himself. So we got 4, 3, 2, 1, add them up, 7, 9, a total of 10 handshakes. Okay? So it kind of goes in a pattern here. You keep on getting 1 less handshake, and then you add them all up. Now, another way of doing this would be, okay, let's put this correct answer in, so it would be 10 handshakes. Okay, well, and again, like let's say if you had 9 people, just if you had 9 people, then person number 1 would shake what? 8 other hands, right? Person number 2 would shake, we already got 1 and 2, 2 doesn't shake itself, so 7, right? You keep on going down 1. Person number 3 would have 6, person number 4 would have 5, and so on. You keep on going down, and then you would, person number 5 would have 4, 6 would have 3, 7 would have 2, 8 would have 1, and 9 we've taken care of. Everything is 0. So when we add them up, 15, 21, 26, 30, 33, 35, 36 handshakes if there were 9 people. Okay? Now, again, on this one, another way of doing this, a little bit more sophisticated way is, in this case, there's 5 people, right? Each of the 5 people shake the other 4. So 5 times 4 is 20 handshakes. But when you're saying each of the 5 shake the other 4, you're counting each one like when you shake number 1 shakes number 2 hand, then 2, when you get to 2, 2 shakes 1. So you're counting each pair shaking double, right? You're counting each handshake. You're counting it twice, but you only need to count it once. So you divide by 2. So 20 divided by 2 is 10. So like if there were 9 people, you would have 9 times 8, right? Each of the 9 shake 8 others, 72, but we counted each one twice, divide by 2, and we would get 36. Okay, so there's a little bit more of a sophisticated method to solve this problem. All right. Number 15, we have Andy, Beth, Dale, and Ella Trier in a 1-mile race. Okay, and we've got we've got 5 runners are in a 1-mile race. Okay, let's try and keep track, and let's see. Let's do one at a time. One information will work. Andy finished 5 seconds before Dale. So let's put the top finishers, the fastest, on top. So Andy's above Dale. So A for Andy, D for Dale, and we'll go ahead and put 5 there for a 5-second difference. Okay, Dale finished 3 seconds before Beth. So Dale is ahead of Beth, so Beth is going to go lower than Dale. And the difference is 3 seconds, right? So we got that one. Beth finished 5 seconds after Ella. So Beth finished 5 seconds after Ella, so Ella is faster. Dale was 3, Ella was 5, so Ella's going to be up here, right? So the difference between Beth and Ella is 5 seconds. Again, Beth finished after, so she's lower, Ella's higher. And then finally we have Tri finished 10 seconds after Ella. So Ella and try would be way down here because this is 10 seconds slower, right? Beth was 5 seconds slower, so try is definitely below Beth. So we can see here from this information, the top one was the fastest, right? Andy, and then the next one would be Ella, would be second, Dale would be third, Beth would be fourth, and Try would be fifth, okay? And that indeed are the correct answers for this one right here. All right, so what I did was I kept track them vertically from the fastest to the slowest, and then we were able to figure out the order of the finishers. All right, very good. Number 16, we've got determine a route whose distance is less than 13 miles for running errands to all 3 destinations and returning home. Okay, what you can do here is just go through one at a time and see which one will give you less than 13 miles. So for the first one we're starting always at home. To the dry cleaners is what? 4.5. Then from the dry cleaners to the post office is 3.5. From the post office to the bank is 2. And bank back to home is 3.5. So we add them up, we get 5, carry the 1, 5, 8, 10, 13.5. Not less than 13 doesn't work. Go to choice 2. We go from the home to the bank, 3.5. Bank to post office, 2. Post office to dry cleaners, 3.5. Dry cleaners back to home, 4.5. Add them up, 4, 6, 9, 13.5 doesn't work. Choice 3, start at the home, go into the bank, 3.5. Bank to dry cleaners, 1. Dry cleaners to post office, 3.5. Post office to home, 5. Add them up, 0. Carry the 1, 4, 5, 8, 13.0. But it's got to be less than. So it's exactly 13, doesn't work. Let's try choice D. We've got home to dry cleaners. Home to dry cleaners is 4.5. Dry cleaners to the bank, 1. Bank to post office, 2. And post office back home is 5. Add them up, 0.5, 9, 10, 12.5. So we finally got one that's less than 13, 12.5, choice D, which is indeed our correct answer. All right, very good. So just keep on going through them, again, until you get something less than the number of miles that you have. In this case, we did the first 3 didn't work and the 4th one worked. All right, very good. We're going to stop this session here. This is your math teacher, Dr. Swears. I hope you found this video helpful. If you still have more questions on any of these problems, send me an email using the inbox through the Canvas course at the FGCU portal. Again, thank you for watching this video.